Hi, this is Coach Heichel. I'm bringing you your very first podcast of the year. This podcast is just going to be basically a very simple review over the review with you rather than just giving you the flat out answers. Actually explaining how I got to the answers so that you can have a better understanding of what we're actually doing. So the first set of questions is, what is the number of significant figures in the following measurements? You don't have to calculate these down here. However, I did, and I'm going to explain to you how to calculate them on your calculators. I'm using a TI-84 Plus. So let's start back over here at 2.708. So we want to know how many sig figs are in that measurement. Well, we have a decimal point. Okay, that's great. That's what we want to look for first. We have a number before it and a number after it and a 0 sandwiched in between an 8 and a 7. So all of those numbers are significant. So you have 4 significant figures in that number. The next one is 16.3050. Well, okay, so we have a number before our 0. So we have a 0 sandwiched between 3 and a 5. So that 0 is going to be significant. This 0 is also going to be significant because it is a trailing 0 after a decimal, and those are always going to be significant because there is a number before it. So you have six significant digits in that number. Your next one is 50.007. Okay, so we have a decimal point. Again, that's what we want it for. So these zeros are sandwiched in between 2 real numbers, a 5 and a 7. So all 5 of those are going to be significant digits. Okay, here's the one that's going to give some of y'all a little bit of problems. So we have 3000010. Okay, so this 3, yes, is a significant figure. All real numbers are always significant. These zeros are sandwiched between 2 real numbers, so those are also going to be significant. The only one that is not significant is this trailing 0 because there is not a decimal point. If there was a decimal point, it would be significant, but since there's not, you got 1, 2, 3, 4, 5, 6 significant figures in that number. Okay. So now to these. When you're adding, subtracting, dividing, multiplying any of these sig figs, remember you have to use the one with the least amount of sig figs for your answer. Since these two are in scientific notation, the exponential power, or this right here, count towards your sig fig. Only the real numbers, okay? Only the 7.8 and 2.4. So after you punch that into your calculator, remember to use the second comma or the EE button for the TI-84s. Don't use the caret because it doesn't work nearly as well. Okay? So you do 7.E second comma or the EE 10 to the 6 minus 2.4 times 10 to the 5th, and that's going to give you this big long number. Sorry, I'm checking my calculator here. It's going to give you 7,560,000. Okay, so it's going to give you 7,560,000. 0, 0, 0, 0. Okay, it's going to give you that number right there. We've got to take that number to 2 sig figs, so we're concerned about these 3 right here. Well, these zeros aren't a significant number because 756 and 7,560,000 are 2 totally different numbers. So we're going to take that 7, okay? That's going to stay where it's at. This 6 is going to have to round that 5 up to a 6. So you're going to have 7,600,000. Sorry, it's being a little slow tonight. So 7,600,000. Because these zeros are not significant. So that's that one. The next one is 2.7 times 10 to the negative 4th minus 3.67 times 10 to the negative 5th. Once you do that in your calculator, you will get 2.33 e to the negative 4th. So let me use this white space right here. You're going to get 2.333 times 10 to the negative 4th. Okay? So you can only have 2 significant digits. This number has 3 significant digits. This number has 2 significant digits. So your answer can only have 2. And again, the exponential power does not count. So it's simply going to be 2.3 times 10 to the negative fourth. The next one, we got 3,200 times 460. So you got to figure out the least amount of significant digits. This one has 2, the 32. These two zeros do not count because there is not a decimal point. 4 and the 6, that 0 does not count because there is not a decimal point. When you multiply those together, you get 2740. Okay? 2,740. So you've got to round that down to 2 significant digits, so you simply just write it as 27 hundredths. Okay, the 4 rounds down, you get 2,700. The next one, you're going to divide. Okay, so let's count sig figs. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So this one's got 6, this one's got 4. So your answer can only have 4 significant digits in it. So when you get your answer, you get 1, 5, 6, 6, 7, 9, 2, 1, 9. So you get this big long number, and you can only have 4 significant digits. So we can only be concerned about these 4. The rest we're just going to fill in with zeros because they're merely placed. 1567. Okay, I like this way the best because it doesn't change your answer, and just fill in the rest. We'll need 5 zeros at the end. There we go. So now on to the next set of questions. So we're going to express the following exponentials as ordinary numbers. So we're going to take these numbers out of scientific notation. Sorry, these aren't as fancy as the other ones. I forgot to put them as superscripts. So it should be 10 to the fourth, 10 to the second, 10 to the negative third. Okay, so we're going to write 7.23. Since it is a positive exponential power, okay, you have a positive 4. That means you're going to move your decimal point to the right, and you're going to make the number bigger. So we're going to go 1, 1, 2, 3, 4. And we're simply just going to fill it in with zeros. So we're going to have 7, 2, 3, 0, 0. Sorry, 72,300. Okay? So your next one, you're going to do the exact same thing. You're going to do 8.193, and then you're going to move it over. It is a positive 2. So you're going to move it over to the right. You're making the number bigger. 1, 2. So now your number is 819.3. So 819.3. And your last one. Okay, this is where it gets a little tricky, and some of y'all are struggling at this. 1.98. Okay. My exponent is a negative 3. So since it's a negative, it's going to make the number smaller. So we're going to move the decimal point to the left. We're going to start there. We're going to go 1, 2, 3. You're going to add zeros. So 0.00198. Okay? Hope that made sense, because this is about as easy as I can explain it. So, on to the next one. Died by drinking chocolate milk. Okay? And there's one exception to this, and we'll get to that here in a minute. So we're going to convert 1 centimeter to 1 meter. So our meter is going to be our base here. Okay? Our meter is going to be our B. So we just simply write 1 here. Okay? And then we're going to write 1.0. Okay? We're going to move the decimal point back 1, 2 places. So that's going to give us 0.001 meters, right? 1, 2. Takes us to deca. Yes. So 0.001 meters. The dk is this side. Okay, it's that D right there. It's not this one. This is deci. This is deca. Okay. So 0.23. Let's write it where it goes. 0.23 Okay, we're going to move it to liter. Our liters are, so we're moving it over 1, 2. So it's simply going to be 23 liters. Okay, here's the one exception where this does not work, but you remember we did the XX micro. Okay, so a microgram is 10 to the negative 6th. So if we start way over here, 10 to the negative 6th with 11, okay, that means we're going to move it over 1, 2, and then we're going to add, we're going to go all the way to kilo. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total decimal places. So we're going to put 8 zeros. Sorry. 8 zeros, 0.000000000, 1, 2, 3, 4, 5, 6, 7, 8, 11 kilograms. Okay, it's a very small number going to a very large number. So yes, it looks ugly, but that's just the way we're going to have to do it. 478 milligrams to kilograms. Again, it's the same way. We go to the M. We're going to do 478 point. Okay, so we're going to kilo. So we're going to move it back. 1, 2, 3. Okay, now we're at base. 1, 2, 3. So we're going to add 0.000478 kilograms. Very good. So let's move on to the next one. Calculate the number of seconds in an 8-hour workday. So this is the dimensional analysis. Okay, we're going to do lots of practice on these in class, so you'll get them down. Always start with what you're given. Well, you were given 8 hours. So let's go ahead and put that set up for our dimensional analysis problem. Let's go ahead and extend this line out because we're going to do a few steps to get our answer. So we're going to take hours to seconds. So we're going to go smaller. So we have an hour here. Well, we know for every 1 hour, we have 60 minutes. Okay? So we're going to cancel out just our unit. We put this hour here because we're trying to cancel it out up here, so we have to divide by that unit. The number doesn't get canceled out, just the unit. The number we're going to multiply or divide at the end. So now we know another conversion where we can get this minute down to a second where we're looking for. So we know that for every 1 minute, we have 60 seconds. So we can cancel out just the units, okay? So you simply multiply. You do 60 times 60 times 8. 60. So it's going to give you 200. Or sorry, not 200. It's going to give you 28,800. Since we only have one significant digit in our question, that's the smallest number of significant digits, we can answer that. 28,000 is simply going to round up to 30,000 seconds. Okay? And remember, you have to put a unit. In science, we measure with units. To 30,000 what? Be sure you put your unit. On to the next one. Convert nanometers to meters. So again, you go back to the King Henry. Died by drinking chocolate milk. Okay? So, King Henry died by drinking chocolate milk. XX. That's the sign for micro. Is a little u. Then, a nanometer is actually 3 more places out. So, it's 10 to the negative 9th. So, we know that if we have 3.7 here, we're going to move it back. We're just going to put 8 zeros in front of that. So, 0.000. It's 3, 4, 5, 6, 7, 8, 37 meters. And the reason we did it this way is because we have a meter, or a form of a meter, and we're going to a regular meter. So we're going to the base right here. The base can be meters, it can be liters, kilograms, Or not kilograms, it can be grams, meters, liters, something like that. So we're going to calculate the number of hours in 5 days. So always start with what you're given. We're given 5 days. Okay, again, let's extend this line because we're going to do multiple steps to get our answer. Well, we know that for every 1 day, we have 24 hours. Okay? Be sure to write our unit down here so we know that the unit cancels out. So that one's pretty simple. It's just a one step. You do 5 times 24. And there are 120 hours in 5 days. But that answer is not accurate. That answer is not correct because we have to use one significant digit. So we're just going to have 100 hours in 5 days. Very good. So that was the end of it. Let me go back to this one and let me erase some of these and let's do one where you have to actually divide because there are going to be some that you're going to have to divide by. And I'm just going to make this up off the top of my head, so just bear with me a second. Let me change my ink color here. Let's change it to blue. Alright, so let's say we have 300,000 seconds and we want to figure out how many years that is. Okay, 300,000 seconds to years. Always start with what you're given. You're given 300,000 seconds. Okay, let's put our line. This one's going to be lots of steps. So we're going from something really, really small to something really big. Seconds, relatively small. Years, relatively big. So we know that there are 1 minute is 60 seconds. We're going to cancel out the unit, not the number, just the unit. So our next increment of time, we can take a minute to an hour. So for every 1 hour, we have 60 minutes. Okay? So again, we're going to cancel out the unit. We're going to leave the numbers there because the numbers are going to become important. So let's get rid of this hour. So 1 day, we can go 1 day now, is 24 hours. Cancel out the hour. We're going to leave the day. We can go days to year, right? Of course we can. We know that there are 365 days. 1 year. So we're left with our answer. Answer should always be in the top box if you did it correctly. So now we have 300,000 divided by 60 times 60 times 24 times 365. I highly suggest you multiply your 60 times 24 times 365 first. Okay, so if you multiply those first, you get this number. You get 315. You get 315. 3600. So then you just multiply 300,000 by this number, not this number divided by that. You should get a decimal on this. So you do 300,000 divided by 315,36000, and you should get 0.009 with a whole bunch of numbers after it, but I'm going to leave it there because I can only have one significant digit because I was given one significant digit there. So 0.009 years, or 9/1000ths of a year. So I hope that clarifies a little bit of everything. I'm not going to go over the multiple choice questions just because I think they're relatively simple, and you should be able to get most of them right. If you have any questions over those, just feel free to ask. So this has been Coach Heichel. Have a wonderful day, and if you need anything, please let me know.